Hey guys, in this video we're going to recall some basic properties of the logarithm function, just in case you've either never seen it before or want a quick refresher on how it works. So the logarithm function will be defined in the following way. So if we're given an exponential function of the form y of x equals b to the power of x, where b is some fixed base and b should be greater than 0, b bigger than 0, then y inverse of x is equal to log to the base b of x. In other words, these two functions are inverses of each other. The logarithm to the base b is the inverse of the function b to the power of x. And what that means is that if we put b to the power of x inside the logarithm function, if we put b to the power of x inside the logarithm function, we should get x out again, because y inverse of y of x is equal to x again. So if we put y of x into the inverse function, the thing that comes out should be x again, because y inverse sends y of x back to x. So what this tells us is that log to the base b of b to the power of x is equal to x, and that comes from putting y of x into y inverse of x. Okay, well, another way to express this, I guess, is that y equals b to the power of x if and only if log to the base b of y equals x. So actually, these two statements are the same, really. These two statements are equivalent, because all we're doing is putting y into the logarithm with base b function. The if and only if may be a bit suspect to know that it actually does go in both directions. So starting with this one, we can also deduce this. You have to realize that the logarithm function is also a one-to-one function because it has an inverse. So inverses always are one-to-one functions, and so is the logarithm function, because we just called it the inverse of the exponential function. So by definition, it's one-to-one. Hope that's clear. Okay, so the first rule we're going to prove is called the power rule, and the power rule says that log to the base b of y to the power of n, by the way, this is the same y here, so we're keeping y the same, log to the base b of y to the power of n, well, we know that this is equal to log to the base b of b to the power of x. And we're taking that thing to the power of n, because y is just b to the power of x. Well, b to the power of x to the power of n is b to the power of n times x. So this is equal to log to the base b of b to the power of n times x. And then now, by this rule up here, instead of putting x here, we're putting n times x. So the thing that comes out should be n times x. So this is equal to n times x. This is equal to n times x. And of course, by this property here, we know that x is equal to log to the base b of y. So what this is actually equal to is n times log to the base b of y. So in other words, when you put something to the power of n into the logarithm function, the thing that comes out is actually n times the logarithm function to whatever the base was to the power of n. So that's called the power rule. Log to the base b of y to the power of n is equal to n times log to the base b of y. All right, so rule number 2. Rule number 2. I guess this is called the multiplication addition rule. I'm not quite sure what it's called, but you'll see what I'm going on about in a second. So let's in this instance, let y1, so given y1, let's let it equal b to the power of x1. And given y2, let's let that equal b to the power of x2. 2 for our base b. And as long as y1 and y2 are both positive, as long as y1 and y2 are both positive, we can find x1 and x2 to make this true. We can find x1 and x2 to make this true. Okay, so given that, then log to the base b of y1 times y2, we know that this is equal to log to the base b of b to the power of x1 times b to the power of x2, and this is equal to log to the base b of b to the power of x1 plus x2. And then we go back to our previous board and we see that actually, well, all we're doing now is putting x1 plus x2 in here instead of x. So the thing that comes out should be x1 plus x2. And this is equal to x1 plus x2. And now remember from the previous slide that y1 equals b to the power of x1 if and only if. So y1 equals b to the power of x1 if and only if log to the base b of y1 equals x1. In other words, this x1 here is log to the base b of y1, and this x2 here is log to the base b of y2. So that's what it's equal to. Equals log to the base b of x1 plus log to the base b of x2. So we started out with log to the base b of y1 times y2, where these are two positive numbers, and that's equal to, yikes, I made a mistake here, log to the base b of y1 plus log to the base b of y2. So we started out with two positive numbers, y1 and y2. Log to the base b of y1 times y2 is therefore equal to log to the base b of y1 plus log to the base b of y2. All right, rule number 3, the division rule. Number 3, so we'll stick with the same y1 and y2. In this case, we'll take log to the base b of y1 divided by y2. Well, that's equal to log to the base b of y1 times y2 to the negative 1. By our previous rule, by the multiplication rule, this is equal to log to the base b of y1 plus log to the base b of y2 to the negative 1. y2 to the negative 1. Remember, y1 and y2 are still positive numbers. Well, now by our power rule, we bring this negative 1 out the front. And so finally, this is equal to log to the base b of y1 plus negative 1 times log to the base b of y2. In other words, minus log to the base b of y2. So log to the base b of y1 divided by y2 is equal to log to the base b of y1 minus log to the base b of y2. So that's the third one. Rule number 4. So for rule number 4, let's let z equal log to the base b of y. So z is equal to log to the base b of some positive number y. And we know that that's true if and only if, y is equal to b to the power of z. If and only if y is equal to b to the power of z. And log is a one-to-one function. Log to the base any number is a one-to-one function. So, and by the definition of function, if I put this into a logarithm function, and if I put this into a logarithm function, into the same logarithm function rather, they better be the same number. So let's take log to the base a of both sides. We better get the same number after doing the same thing to them. So we have log to the base a this time. Remember, I'm taking a different different base this time. The first one was log to the base b. This one is log to the base a, so it's a different base. So log to the base a of y is equal to log to the base a of b to the power of z. So if you're confused there, don't worry. I didn't do anything special. All I did was take this y, put it into the log to the base a function, and I took this b to the power of z and put it into the log to the base a function. And since these are the same function, if I'm putting the same thing into them, the same thing better come out. Otherwise, something's wrong with reality. So, given that nothing is wrong with reality, I hope, these two things better be the same. And now we can use our power rule. Now we can use our power rule because we can bring this z at the front by the power rule. So this tells us that, in fact, log to the base a of y is equal to z times log to the base a of b. And therefore, z is equal to, well, we're going to divide both sides by log to the base a of b because that's just a number. So z is therefore equal to log to the base a of y divided by log to the base a of b. And since z is also equal to log to the base b of y, we must have that log to the base b of y is always equal to log to the base a of y divided by log to the base a of b for any number a that we choose. So you can choose any base a, then log to the base b of y is always going to be equal to log to the base a of y divided by log to the base a of b. That's pretty important. Finally, two easy ones. So number 5, well, log to the base b of b is the same as log to the base b of b to the power of 1, and we know from our definition of log that that's equal to 1. So log to the base b of b is equal to 1. Log to the base b of b is equal to 1. And finally, the last rule we're going to cover in this video, log to the base b of the number 1 is equal to log to the base b of y to the power of 0 for any y you choose. And that is equal to, again, by the power rule, we bring the 0 down the front. So that's equal to 0 times log to the base b of y, and that is just equal to 0. So in fact, for any base b, log to the base b of 1 is always equal to 0. And that's our final log rule for this video. Okay, thank you very much for watching. Hope that was useful. See you guys next time. Bye.